chapter 7, lesson 5 on page 553 on similar triangles and indirect measurement. Have you guys ever tried to measure something really tall?
Yes.
Yes. Or something really long without the, yeah. So this is a cool lesson. It's about indirect measurement. We could measure the height of this building through indirect measurement if the sun was out. And the sun's not out. So we can't do it today, but we will do it soon. So here's an example. See this kid and this kid, maybe he's like 5 feet tall. Would you say that his shadow is 5 feet tall?
No.
No, it's way longer than 5 feet tall. So there's this triangle, like if you were to look sideways, there's this triangle, I guess, between right there. Top of his head and the shadow, and then right here it would be perpendicular, but you can hardly see it. So here's a better example. So this is Thales. He was the very first Greek mathematician, and he figured out the height of pyramids by similar triangles. So he knew the height of his staff, and then he measured the length of the shadow. He wanted to know what is the height of the pyramid, and he measured the length of this shadow. Which angles are going to stay the same? Like the sun would have to be somewhere like here. Would you guys agree? If this was the sun shining, it's going to make the same angle with both of these things. So this angle has to equal that angle. And you can use that, use the proportions to figure it out. So what appears to be true about the corresponding angles? So they're congruent. They're congruent. Make sure you spell "there" correctly. If the corresponding sides are proportional, what could you conclude about these triangles? They're what? They're proportional, and if they're proportional, they're called what?
Similar.
Yeah, similar. They're similar. Good. All right, so let's go to things. So indirect measurement is basically what you use to measure things that are not safe to measure on your own. Like, is it safe to measure the length of your arm?
Yeah.
Yes. Would it be safe to measure the length of the Statue of Liberty's arm?
Yes.
Safe?
Yes.
Could you just like go there and like Spider-Man it up there and like, hey, take the tape measure? Yeah, not going to work for most people, right? So that would not be safe to. So what's something else that you could easily measure pretty, like really easy? Oh, a pencil, okay.
Paper.
Pencil, paper, maybe like a ruler. That would be really easy to measure, right? And then what are things that would be too big or difficult to measure?
Eiffel Tower.
The Eiffel Tower.
Skyscraper.
Skyscraper. Or maybe like the depth of the Grand Canyon. Any of those types of things would not be safe to measure. So they use indirect measurement, and they can still actually find out the real length of it because of proportions. So this is a cool thing. This is a key concept. Is if you had two triangles and you knew that two of the angles were the same, that's all you have to know. Is that two angles are the same and the triangles are similar. Boom, bada, bum. So you only need two of them, because what do we know about that third one? They'd have to be the same too. How many degrees do all the angles inside of a triangle add up to? 180, right? They all add up to 180. So they are just showing an example of that. Determine whether these things are the same. So we have 62 and 48 and 62 and 70. Oh dear, what are we going to do? Well, let's see. What can we figure this one out? How? We could subtract them from 180. So calculators out, please. 180 minus 62 minus 48. And what do you get? 48. 70 degrees. Now what can we say? Because I have 62 and 70. I have 62 and 70. Do I even need to figure this one out? No, because I have two angles. And so then our final statement can say that they are similar. Okay, we have 110 and 110. We only have one angle measured here. What do we know? What do we know about this angle right there and that angle right there? What are those called? They make V's. Vertical angles. So I want to talk about this angle and I want to talk about that angle right there. So watch how I have to do it. I'm going to start with L, go to K, and end at M. So I'm going to put angle L, K, M is congruent to, now I want to do the same thing. HKJ, good. Angle HKJ. And then I'm just going to put because vertical angles. And then I'm going to put so by angle similarity. You should be writing all this down.
Yes.
Triangle LKM is similar to triangle HKJ. Okay. Because we have two angles. We know those two angles are the same and those two angles are the same. Do we need to find J or M? Do we even need to find out what that angle is at K? No. All we need to know is that they're congruent and we're like so done. It's nice, huh? I'm so done with that problem. Okay. So here's an example of indirect measurement. We've already talked about the first part, so I'm not going to have it be there.
You should teach in an accent.
I could teach in an accent. Do you want me to teach this in an accent?
Yes. Try.
I'll do it in a Scottish accent, which is similar to Shrek. So we have right here, you can't really measure a light post. Has anybody ever tried to measure a light post or tried to climb up to the top of it?
Yes.
It's dangerous, right? And then some light posts are really cheap, and then what would happen is the light post would just fall right over. And then it's dangerous for everyone. And then what if the glass broke? It's just not safe. But what you can measure is a fire hydrant. So if they measure the fire hydrant and then measure the length of the shadow, you can compare that to the length of the light post, given that that shadow isn't going in the middle of a busy street, because that too would be dangerous, right? So we measure those things and we can figure them out. So what they did is they took the actual thing, they took the height and the shadow. So we have the height of the fire hydrant and the height of the street light, and you compare it to the hydrant shadow and the street light shadow, do the cross products, and then you divide, and voila. Because I'm a French Scot, you have the street light is 13 feet tall. Does this make sense?
Yes.
You're gonna be doing this on your homework, on all 4 problems. Next part is another example of this. Do you want me to switch accents?
Yeah.
French? I'll do French now because that was only fitting.
Okay.
I'll do French. In this figure, it is really impossible to measure the length across a lake, because have you ever tried to take your hose and pull your hose so it's a perfect line?
Yes.
You can't do it. What happens to the hose? It has this little bend on it. It makes it look like a ball. And it can't do that. You can't pull it straight. It's too heavy. You cannot take a tape measure and measure across the thing. Besides that, you'd either have to get a boat or be able to have submarine equipment to go underneath the water. So instead, you can measure things that you do know. You do know this length right there, and you know the entire length here. So how many triangles do we have?
2.
So I'm going to go like this. I'm going to take the measurements from my small triangle and then my large triangle. The smallest side is 40, and the long side, what is the long side that we have from the small triangle?
320.
320. And then we have, we don't know this short distance on the long one, so we put D there. And how can we find out the entire length of this long side? And adding, very, very tricky. What is 320 plus 162?
482.
482. So is to 482. What is the next and last step? Like there are 2 more steps. Cross multiply. So what do I write with my cross multiplying? 320 D is equal to
1902.
19,280. And then last step we have to do,
Divide by 320.
divide by 320.
6.025.
So the answer is 60.25 meters, just like this right here. And voila.
You showed it to Sebastian. It's great.
For last problem, we're going to try these together. These can be a little bit difficult because you have these words and you have to read them. Yes, it's very hard. So we have to take these words and read them. It says, at the same time, a 2-meter street sign casts a 3-meter shadow. So let's go like this. We are going to go this sign. We have this sign. So we have 2 meter and 3. And then we have the telephone pole.
Wait, is this right?
Do we know how tall the telephone pole is?
Ms. Palmer,
Yes.
I have to.
So then we take, do we know height of telephone pole? So what letter do we want to use?
T.
T. That's really creative. She thought all day, what are we going to call telephone pole? And then we have 12.3 right here. Now what do we do? What do we do?
Multiply.
So we would have, what's the number that's going to go next to T? 3T is equal to, and then
I already figured it out.
2 times by 12.3.
24.6.
And we have 3T is equal to 24.6. So T is equal to
8.8.
8.2. So the telephone pole is equal to 8.2 meters. Homework is either 4 whole problems on Alex, or I can tell you book numbers if you want book numbers. Either way.